Mechanical properties of material are strength, toughness, elasticity, plasticity, stiffness, ductility, malleability, hardness, creep, fatigue, resilience, etc. Let us dig into more details. Strength. Strength of a material is the ability of a material to withstand stress without failure, or the capacity to withstand destruction under the action of external load. There are multiple variants of stresses acting on the material when it is in use. The three common types of stresses acting on the materials are tensile stress, compressive stress, and shear stress. The ability of a material to withstand a stretching load without breaking is called tensile strength. Similarly, the compressive strength is the ability of a material to withstand a squeezing load without breaking. Shear strength is the ability of a material to withstand load which have a cutting action. For example, when we use a scissor, the shear stress is happening on the material. This chart shows strength of many materials. Here, composites and metals having higher strength compared to the ceramics, foams and polymers. Toughness. Toughness is the ability of a material to withstand a sudden impact or a hammering load. So this is also called impact strength. Here is an example of more tough and more fragile products. Elasticity. The ability of a material to deform under a load and return to its original shape when the load is removed is called elasticity. If you stretch an elastic or a spring, that will get stretched out. When you remove the force, that will return to its original shape. In this stress strain diagram, it is evident that stress is directly proportional to the strain up to a certain force acting on a material. So this region is called elastic region. Plasticity. This is the ability of a material to deform under a load and retain its new shape when the load is removed. That means the material is not going to return to its original shape. The clay undergone plastic deformation and attained its new shape. Per this stress strain diagram, if the force is applied on the material after the elastic limit, the material will undergo plastic deformation and it's not going to get back to its original shape. Stiffness. Resistance of a material to elastic deformation or deflection is called stiffness or rigidity. For example, while stretching or compressing a rod, the stiffness is defined as K. K is equal to F by delta. F is the applied force and delta is the deflection. If the material is having higher strength, it is hard to broken. If the material is having higher stiffness, it is hard to be deformed. Glass having lower strength and higher stiffness, while spring having higher strength and lower stiffness. Ductility. The ability of a material to be stretched into wire without breaking is called ductility. This is the term used when a material is deformed by a tensile load. You can see an example of SS and copper which are stretched into the wire shape. This is the stress strain curve of a brittle and ductile material. The ductile material absorbs more energy and stretched and elongated as shown in the figure. Malleability. The ability of a material to be hammered into a thin sheets without cracking is called malleability. You can see here coins and platinum foil which are formed into a thin sheets. Gold is the most malleable material. Hardness. The ability of a material to resist scratch, abrasion, cutting or penetration is called hardness. This is the ability of a material to withstand scratching by another hard body. Material can be hard or soft as shown in the images. This chart shows hardness of different material based on the testing. Feel free to pause the video and look into the chart. Creep. The slow and progressive deformation of a material with time at constant stress is called creep. Creep is a type of metal deformation that occurs at stresses below the yield strength of the material. Generally, it will happen at elevated temperatures. This image shows how creep start and end with the failure. Creep can happen in 3 stages: the primary creep, secondary creep and tertiary creep, and end up with the failure. Secondary creep will undergo a large duration compared to the primary creep and tertiary creep. Fatigue. Fracture of a material because of the repeated or fluctuating loads are called fatigue. Fatigue fractures are progressive. At the beginning stage, the crack size would be very small and gradually increase the crack size under the action of fluctuating stresses. Here is the image of fatigue fractures happened in multiple components. Resilience. Resilience is the capacity of a material to absorb energy elastically. Nylon has excellent resilience. The stress strain diagram shows the resilience of a ductile material. The area under the elastic region is called elastically absorbed energy or resilience.